RAG stands for retrieval-augmented generation, and RAG is typically used as an external knowledge base for the LLM. This is because LLMs that we use in Cline largely have a knowledge cutoff date, meaning these LLMs only have knowledge up to the point of the training data that was used to train the model. While RAG is often discussed in the context of indexing a codebase, here we're referring specifically to RAG as a way of extending an LLM with external knowledge base beyond this training knowledge cutoff. For example, Claude Opus 4, which is a popular coding model in Cline, was released in May 2025. However, the knowledge cutoff date is March 2025, which means Claude Opus 4 has static knowledge up to March 2025 until Anthropic releases another minor release that updates its training data. To overcome this limitation, some techniques were introduced, most notably MCPs that give LLMs the ability to search the internet and scrape the contents as a context. This means that if the LLM thinks it needs more information beyond its training data, it has the ability to search the internet to load them as relevant context. However, there is another method to this, which is known as RAG. RAG essentially allows LLMs to augment its knowledge beyond its training data to use whatever information it retrieved as a data source. So let's break it down into 3 steps to dig a little bit deeper: retrieval, augmented, and generation. Let's say your prompt to Cline was this: can you update our company homepage to include the company's refund policy on shoes? With RAG, the LLM will retrieve relevant details about the company's policy returns on refunds and narrow down to the specifics of policy on shoes. Once this LLM makes this request, the result that contains information about the company's refund policy is added to the context before the LLM starts updating the company's homepage in the source code. So in this case, the LLM essentially augmented its knowledge as if it knew about the company's policy and generated a response that was influenced by the retrieved data. While this entire process of RAG seems extremely streamlined and useful, you typically pay the price during setup. And setting up a RAG system is more art than science. So going back to our earlier scenario, the entire company policy documents need to be converted from its original document type to an embedding to be stored in a vector database. So essentially, you are adding overhead whenever you add or change the company's policy to store them in an alternative database. And on top of that, storing these documents into a vector database is often trickier when you consider the decisions that need to be made, like proper chunking sizes, chunk overlap, and dimensional space. So as convenient and cool as RAG is in what it can do to extend and augment the knowledge of an LLM, it's only as good as all the work that goes into the setup. So as you can see, RAG can add significant overhead with limited upside, which is why Cline does not index your codebase, but rather uses Cline's agentic exploration to load the proper context instead of RAG. However, RAG can certainly be helpful in quick retrieval of semantic similarities for retrieving a large set of documents that the LLMs can use, especially for privately hosted information. So understanding what RAG is and what benefit it brings can help you when or when not to use RAG in your software development lifecycle, depending on your business requirements.